All right, today I'm going to review you for the physics exam. Remember that it is a two-part test. First part is multiple choice. The second part is free response. First, on your test, you will be given all the formulas that you need to calculate force, density, speed, volume, power, and work. So, the things to remember about the graph is that velocity is shown with a straight line. This is going up into the right, so that means it is in a positive direction. This horizontal line means that the object has come to rest. And this line that is going down at a straight line means that it is going in a negative direction or decreasing. The other type of line that we can see on a graph is an acceleration line. Accelerating means that you are not going at a constant speed, that the object is accelerating and increasing speed, but at different intervals. So instead you get a nice curved line. This means that we are curving in a positive direction. If we had a line that curved down, it would mean that we were accelerating in a negative direction. All right, you also have to be able to read a graph and tell me different information. So we're going to use this graph right here of this car that traveled 60 kilometers in 60 minutes. You have to be able to tell the speed of the car. So you have to remember that speed is equal to distance divided by time. You have to be able to tell me how far it traveled. So in this case, if we come here to the last point, we know that it traveled 60 kilometers. And because this is a nice straight line, that tells us that this is a constant velocity. And be able to determine the acceleration between 2 points. So here's 3 practice problems. So one says, what is the acceleration between 50 minutes and 60 minutes? So at 50 minutes, we were at 50 kilometers. And at 60 minutes here, we're at 60 kilometers. So 60 minus 50 means that the acceleration between 15 minutes and 10 minutes is 10 kilometers. Number 2 says, how far did the car travel between 10 minutes and 40 minutes? So again, at 40 minutes, we were at 40 kilometers. And at 10 minutes, we were at 10 kilometers. So it traveled a total of 30 kilometers between those times. And then 3 says, what is the speed of the car after 20 minutes? So at 20 minutes, we were at 20 kilometers. So 20 kilometers, which is our distance, divided by 20 minutes, which is our speed, means that we were going, our speed is 10 kilometers per minute. Now, because this is a nice constant line, every single point is 10 kilometers per minute. So that is the slope, also known as the speed of the line. Remember, we can simply do this by rise over run. If we move up to 10, and then we move over to 10, our rise over run is 10 kilometers per minute. All right, so let's move on. All right, so you also have to know how to do balanced and unbalanced forces. So a balanced force means that there is going to be no motion. The object does not move. So in this case, we have 5 newtons to the right and 5 newtons to the left. When they go in opposite directions, so when they go in opposite directions, which means that they can either be pulled away from each other or be pushing towards each other, we subtract the number. So in this case, 5 minus 5 is 0. So the net force is 0 newtons, meaning it is balanced and it will not move. If the objects go in the same direction, so either they push together to the right or to the left, or they pull together to the right or to the left, we add those numbers. So on this second one, we have an unbalanced force because we have 5 newtons going to the left and 2 newtons going to the right. 10 minus 5 means there's a net force of 5 newtons. And it will go in the direction of the greater force. 10 newtons is greater than 5 newtons, so it will move to the right. So again, an unbalanced force, if the objects that will move in the direction of the greatest force that's acting upon that object, To find the net force is when they're moving in the same direction, we add. When they're moving in opposite directions, we subtract. And remember, our units are N for newtons. All right, there are types of gravity or types of force that are working against an object. These are the ones most common on Earth: gravity, friction, magnetic, electrical, and centripetal. One of the questions on your free response page, it shows a skater, and she is jumping off of the ice, and it has an arrow. And it's going to ask you to I'm sorry, it's going to ask you to label the action and reaction for Newton's third law. Well, in this case, because a girl is pushing off of the ice, that is the action. And the fact that she jumps, that is the reaction. And again, I believe this is question number 12 on your free response. But what the forces that are working on her, the force that is pushing down on her, of course, is gravity, and then the ice is pushing back on her, which is what makes her goes up. So those things can go together. All right, so Newton's three laws. You must know that Newton's first law is a law of inertia. An object at motion will stay at motion. An object at rest will stay at rest unless acted upon by an outside force. Now, the key thing to remember about this outside force is, one, it has to be unbalanced, and number two, any time an unbalanced force acts upon an object, the object will always, always, always accelerate. Now, that either means that it's accelerating because it's speeding up, or it's accelerating because it's decreasing in speed. I believe this is question number, I want to say either 6 or 9 on your multiple choice part. It's going to ask you, and it will tell you when an object is acted upon an outside force, the object always does what? And the answer is accelerates. Newton's second law is the law of force and acceleration. The force applied to an object will move in the direction of the greater force. So remember, the formula is force equals mass times acceleration. Remember, you can use the triangle formula where force equals mass times acceleration. This line that goes up and down means multiply. This line that goes horizontal means divide. So if I'm asked for mass, I can just simply cover that up, which means it's force over acceleration, which means divide. And then Newton's third law, action and reaction. For every action, there's an opposite and equal reaction. All right, here are some practice problems that you can do to help, because most of your multiple choice part will be finding density, finding speed, finding force, those kind of things, using all those formulas from above. So one of the things you have to remember to do is how you convert from minutes to hours. Well, 25, the easiest thing to do is to take your minutes, so it's 45 minutes, and divide it by the fact that there are 60 minutes in an hour. So 45 divided by 60, and of course you will get to use a calculator, is 0.75. Or hopefully you know that a quarter of an hour, I'm sorry, 0.75, a quarter of an hour is 0.25, half an hour is 0.5, 3/4 of an hour, which is the same thing as saying 45 minutes, is 0.75. So now we want to find speed. Speed is simply distance divided by time, so you want a total of 4 kilometers. We're going to divide that by 0.75 hours, and 4 divided by 0.75 is 5.3 repeating kilometers per hour. A car travels at 100 kilometers per hour. How many hours does it take? Remember, if we use our triangle, speed is equal to distance divided by time. So if we're looking for time, that's distance divided by speed. So we take our distance of 750 kilometers. We divide it by 100 kilometers per hour. That gets rid of our kilometers, and that's 7.5 hours. All right, 2 different ways we can find density. First, we're given the mass and the volume. And we know that density is equal to mass divided by volume. So our mass here is 50 kilograms. Our volume is 5 milliliters. So 50 divided by 5 is 10 kilograms per milliliter. The other way we can find density is if we're not given volume. Because remember, we can find the volume of a cubed object by length times width times height. So this is a two-step problem. You have to find volume first, and then you can find density. So because it is a cubed object, we hope that all the sides are 5. So it's 5 centimeters times 5 centimeters times 5 centimeters. And if you do that, or 5 to the third power, it is 125 centimeters cubed. Now, the second part of this is then to calculate density. So again, we know that density is equal to mass divided by volume. So mass is 30 grams. Density is 125 centimeters cubed. And remember that 1 centimeter cubed is the same thing as saying 1 milliliter. So you take 30 and divide it by 125, and you get 0.24 grams per centimeters cubed. Remember that there's one other way we can find volume. If we do not have a regular shaped object where we can take length times width times height, then we can find the volume of an irregular shaped object. And this is called water displacement, which is where if you have a graduated cylinder and you fill it up to 10 milliliters, then you drop the object into the water, and wherever it rises to, so let's say it rises to 12 milliliters, the water displacement is 2 milliliters, so the volume is 2 milliliters. All right, one more free answer that I'm going to give you is one on your free response. You are going to have to be able to read a graphing problem and graph it. So remember that time goes on the bottom in whatever units, and distance is your y-axis in whatever units. So I believe it asks, or it says something to the effect of that for the first 4 seconds, the object moves 2 meters per second. So at 1 second, we're at 2. At 2, we're at 4. At 3, we're at 6. And at 4, we're at 8. So then we should get this nice little straight line here. And then it's the object comes to rest for the next 3 seconds. So 3 seconds plus 4 seconds is 7 seconds. So we get this nice horizontal line. And then it's going to decrease 1 meter per second for the next 3 seconds. I'm sorry, no, it says it's going to decrease 2 meters per second for the next 3 seconds. So at 8 seconds, we would be at 6 meters. At 9 seconds, we would be at 4. And at 10 seconds, we would be at 2. So that you should get this nice shape like this on your graph. All right, so I hope, I wish you well on your test, and hope you do good.